Now we're going to look at energy demand. So households care about services, and commodities are used to produce these services. So when we think about a household utility function for energy, we're going to think about services entering the utility function, not commodities per se. Households have holdings of durable goods that convert energy commodities into energy services. So durable goods are things like light bulbs, cars, water heaters. Energy commodities are electricity, gasoline, natural gas, and energy services are lighting, transportation, hot water. So it's not as what I mean by what enters the utility function, it's not as though we get more utility from having more light bulbs. What we get utility from is the lighting that the light bulb provides, the service that the light bulb provides. We don't necessarily get utility directly from water heaters, but we get utility from the hot water that the water heater produces. Quantities of these energy services consumed are what enter the household's utility function, not consumption of energy commodities. Energy usage depends on energy service, consumption, and energy efficiency. So two components. Total energy usage depends on how much energy we're using and the energy efficiency of the appliance we're using. So how energy efficient the durable goods are, miles per gallon for a car, whether or not you have a front-loading washer. Front-loading washers are more efficient than top-loading washers, or an electric water heater. Those tend to be more efficient than a natural gas water heater. And then the second component is how much of the energy service the household decides to consume. The quantity, how long of a shower you take, how many loads of laundry you do, how far you drive, etc. So let's put this into a little bit of mathematical context. How much energy commodity must be consumed to produce a given service? Well, first we have to consider what is energy intensity, the number of units of the energy commodity required to provide 1 unit of the service. So this could be kilowatt hours of electricity per hour of lighting, liters of gasoline per kilometer driven, or gallons of gasoline per mile driven. So let's let small q be equal to the quantity of energy using services consumed. Let small e be equal to the energy intensity of the durable good used to provide the service. This is going to be the miles per gallon, the efficiency of the appliance. And then let large q, little e, be the quantity of the energy commodity consumed, and that is QE equals the product of little q times little e. Now we can talk about the demand for energy services, and the demand depends on the price for each unit of service, of course. So if we're going to write down a demand function, we know that price has to enter that equation. The quantity Q, little q of energy using service is chosen by the household, and the choice will depend on the price for each unit of service. Households have a demand function for energy services. For example, little p for a car will be the price for 1 kilometer of driving. So little p in the third small bullet point after the EG, that's the little p in the equation at the bottom of this slide. This little p is going to depend on the price for, in the case of driving a car, the price of gasoline and the efficiency of the vehicle, E. So the energy service price P, little p, depends on the price of the energy commodity, large P, and the energy intensity of the durable goods. So again, in the case of driving, little p is the price of driving your car, which is a function of the price of gasoline, large PE, times the efficiency of your vehicle, the miles per gallon it gets.